All right. Did you get either one of them? You got the first one?
Got the first one.
Now, what you needed to recognize on the first one is what? It factors. Did you recognize the top is really just 1 minus 3n minus 4n squared? That's what the top is. It's just a little quadratic. So the top is going to factor as 1 minus, now think about how that would factor. That would be 1 minus 4n, 1 plus n, wouldn't it?
Yeah.
So this will be 1 minus 4 cosine and 1 plus cosine. Now, what about the denominator? It's a sine, and you need it to be a
1 minus
cosine, so you're going to change it into 1 minus cosine squared. Because, pay attention to what the end result is. Now, what about 1 minus cosine squared? We've done this a lot. What do we do with that?
Cosine, 1 minus 2.
That factors. And you can cancel, and you are left with what you wanted. Okay?
No way.
All right, let's look at the one on the back. What was your thought when you looked at this one?
A common denominator.
Get a common denominator. All right, you can do that. Okay, so our common denominator will be this, right? So this one is going to need to be times by 1 minus tan.
That'd be
And this one is going to need to be times by 1 minus cosine.
That'd be tan minus 10 squared.
So yeah, when I write down my numerator, this is going to be tan minus tan squared plus cotan minus cotan squared. This is a real mess because nothing is going to cancel out. You see that? Since like you've got tans and cotans, but they're not being added. I mean, they're not being multiplied. They are being added together or subtracted. I think I'm going to try something different. That's not a bad plan. That's not a bad plan. But that's a mess. What might be, let's go back to the beginning, the original problem. What might be another strategy? What do we do a lot in almost every problem? Change into sines and cosines. So let's take this fraction and let's see what happens if we change it into sines and cosines. Maybe nothing. Maybe we'll still have a mess. Let's see. Sine over cosine. You may, since I only gave you a half sheet, you may need another sheet of paper. Sine over 1 minus cosine over sine. And then plus, we'll do the same thing here. Cosine over sine over 1 minus sine over cosine. Now, we've seen this before, this kind of thing before. What might we do next? Look at just this one right here for a moment. This is a separate fraction. These are two separate fractions, right? What could I do to clean that one up?
Times everything by sine.
Not just sine,
Sine, cosine.
sine and cosine. So I'm going to multiply everything by sine, cosine. And actually, this one will be the same, right? Now, let's hope something good comes out of that. All right, what do I have on top here? That's just going to be sine squared over sine cosine minus cosine squared. Oh, I should have done this problem before I put it on the paper. It looked like it was going to be a big one.
Yeah.
It's a big one.
Pretty simple.
Let's see something here real quick. Let's factor this denominator. And let's factor this denominator. Okay, this is way more than I expect you to be able to do, but let's finish it real quick. I'm just going to go through it real quick so you can see. This is going to involve something tricky, I think. First of all, these two pieces of the denominator are pretty close, right? They're just opposites of each other. So I'm going to go ahead and take care of that. Just right off the bat here, just in a step. I'm going to go ahead and I'm going to make this a minus because I am going to turn that one around so that those two pieces at least match. So I'm basically factoring a negative out and writing it out here in front. Now the denominators are almost the same except this one needs a sine and that one needs a cosine. So I'm going to give this one a sine, give this one a cosine, and now, as hideous as those denominators are, they match. So my numerator would be a sine cubed minus cosine cubed. And then my denominator is all that stuff. Now the numerator is the difference of cubes. So again, it factors, you're not going to have to do this on your quiz, this is more than we bargained for, but that factors, it's the difference of cubes. Now, this part cancels. So what are we left with on the top?
1 plus sine cosine.
1 plus sine cosine over sine cosine. Now I'm going to split that and write it as 1 over sine cosine plus sine cosine over sine cosine. Now, I erased it, but look on your paper. What are we ending up with? What are we supposed to end up with?
Cosecant.
We're supposed to end up with a 1, right? There's a 1. And then 1 over sine is cosecant, and 1 over cosine is secant. Way more than we bargained for. Remember we've been talking about, we got problems 1 to 10. We're only doing 1 to 5s. This is probably like a 7.
It's only a 7.
Oh, they get crazy. Okay, I got a couple of things I want to do real quick to make sure you're ready for tonight's homework, and then we'll look at last night's and see if you had any questions. Tonight you are using the same identities, the sum and difference, that you did last night. We're just going to do a couple of different kinds of problems. For example, you actually memorized this one. Well, you were supposed to have memorized this one. It's one of the co-function identities. Today we're going to prove it. We're going to pretend it's one of those. We're just going to prove it. And it's real easy to do. This is one of the formulas. This is a difference. These are being subtracted. So how do we do the sign of a subtraction? What does our formula tell us to do with the sign of a subtraction? Okay, what's the pattern for sign? Sine of the first, cosine of the second, minus cosine of the first, sine of the second. Is that good with everybody? Now, 90 degrees. Yesterday we did a lot with 30s and 60s and 45s, but 90s are also special. 90s are right here, right? And we talked about before Christmas that if your angle is on an axis, you don't have a triangle and all that stuff. You just know that point. That's the point 0, 1. 2. So this,
Miss Edwards always refers back to that.
Always. That's our unit circle. Yep, we use it all the time. So the sine of 90, remember sine is y, so the sine of 90 is 1. And the cosine of 90 is 0. So when you plug those two numbers in, what are you left with here? What does this equal? Cosine, which is exactly what we knew it was supposed to equal. So tonight you're going to do some verifications just like we've been practicing, only they're going to involve sums and differences. So you will start, step 1 will be your formula. Write your formula out. Got it? Okay. Another kind of problem that you need to be able to do is something like this. It looks very complicated, but it really isn't. Takes forever just to write the problem. Okay, so we're going to find the cosine of x minus y. Now something should pop into your head when you see cosine x minus y. Cosine x minus y, what does that equal? Cosine x, cosine y, plus, good, sine x, sine y, perfect. Now, this problem has x's and y's instead of u's and v's. Nobody's confused by that, right? The letters don't matter. It's cosine, cosine, minus sine, sine. Or in this case, plus sine, sine. Perfect. Now, go back to the given. Could we draw a picture of this? Well, the answer is, of course, yes. Tell me what this is saying.
It's in the first quadrant.
Not the first.
Second.
The second quadrant. Because pi is 180 and pi over 2 is 90. So if we're looking between 90 and 180, we're in quadrant 2, right? So I'm going to draw a picture of angle X. It is in quadrant 2. And what do I know about angle X in quadrant 2? Its sine is,
4/5.
so where does that go?
Hypotenuse 5.
That's 5.
And the
This one is 4 because sine is opposite over hypotenuse, or y over r, right?
-3.
So this would be -3. Now, how did we get that? Pythagorean theorem. Yeah, that's Pythagorean theorem. We know it's negative because it's going this way, right? Everybody okay with that? Now let's draw y. Where are we going to put y? What is it between 270 and 360? Remember, pi is 180.
That's quadrant
Four.
That's quadrant 4, so y is in quadrant 4. And we know his cotangent is -12/5. So adjacent over opposite. So even though I wrote -12/5, the 12 is positive and the 5 is negative. Would you agree with that? Pythagorean theorem would say 13. So we drew a picture of both of the x and y, both of the angles we had stuff about. We drew a picture of it. We wrote out the formula we're going to use. Now guess what we're going to do? We're going to take numbers from the pictures and plug them into the formula. So what's the cosine of x? I need the cosine of x. What's the cosine of x?
-3/5.
-3/5. What's the cosine of y?
-12/13.
12/13. What's the sine of x? 4/5. And the sine of y? -5/13. So now I can multiply these together. -36/65 minus, because it's a minus there, 20/65. So the answer is -56/65. It looked really bad, but it really wasn't that bad, right? You can manage that. All right, get your packets out. And the very front page has some good stuff on it. Okay. You had some of these in last night's homework. Okay? Now, you look at this problem, and let's just forget the numbers for a minute. Forget the numbers. I see sine, cosine, minus cosine, sine. Now, when you say that, it should ring a bell. Something should click in your brain. Sine, cosine, minus cosine, sine. That's one of your formulas. Is it sine, cosine, or tangent? It's sine. So this is going to be the sine of something. Now, that's a minus. You just told me this is a sine problem. So that's going to be a minus, because in the sine formulas, the signs are the same. Got it? Now, what are the angles in the problem? 18 and 13. So it's 18 minus 13, so the answer is the sine of 5. This is a formula for the sine of 5 degrees. See how we process through that? Step 1, figure out if it's sine, cosine, or tangent. Step 2, figure out if it's add or subtract. Step 3, plug the numbers in. All right, so here you go. Forget the numbers. Tan minus tan over 1 plus tan tan. Well, what function is that? That's a tangent formula. Now, minus over plus.
It'd be minus.
It'd be minus. Sine over cosine. The signs are the same for the sine, so that's a minus. It's another minus.
27 and 20.
27 and 20. So this is a formula for the tangent of 7. 27 minus 20. Okay, here we go. Cosine, cosine, minus sine, sine. Cosine, cosine, minus sine, sine. Which function? Cosine. Put your parentheses in there. Now you need a sign here, plus or minus. So this is cosine, and that's a minus, so the formula is going to have a, or I mean, if the formula has a minus, the thing's going to have a plus. What am I adding? 53 and 33. So this is a formula for the cosine of 86. You okay with that? All right. Now, from yesterday, cosine 195. What is your thought on cosine 195? What are you going to do with that 195? 180 plus 15 is okay, but is 15 one of my special angles? Don't want to use 15. Whenever I have a 5, I like to use 45. You don't have to, but 45 is so easy. I like to use it. So that would be the cosine of 150 plus 45. There are many other options. You could do 135 and 60. You could do a lot of other options. Rose, you okay over there? All right, so let's see. If I do 150 plus 45, what's my formula say? Cosine, cosine, minus sine, sine. And we do the 45s all the time.
Root 2 over 2.
So those are root 2 over 2. 150, I'm going to draw a picture of. Again, you might have it memorized, and that's great. I do not. So I'm going to draw a picture of it. And if this is 150, what's this?
Negative. About 30.
Yeah, this number will be negative, but I meant the angle there. Yeah, that's a 30. So this will be a 1 and a 2 and a root 3, and like Dan said, that's going to be a negative root 3. Remember, always across from the 30 goes the 1. Always, always, always. So what's my cosine? Negative root 3 over 2. Negative root 3 over 2. And my sine is 1/2. So here we go with the numbers we always get. Negative root 6 minus root 2 over 4. What do you think about that? Is that okay? If you picked different numbers than 150 and 45, this part of the problem will look different, but the answer will be the same. Everybody needs to get the same answer, no matter what angles you start with. This is one like in tonight's homework. So let's practice it. We only did one, but do you remember how I told you to start? What are we going to do first? We're going to recognize that that is a sum. That's like a u plus v. So we're going to use our formula. So what does our formula tell us to do? Sine 90 cosine x plus cosine 90 sine x. This looks a lot like the one we did before. Was it exactly the same? Oh well. So now what do? Now we figure out the sine of 90. So here's my unit circle. The sine of 90 is 1, and the cosine of 90 is 0. So I am left with just cosine, which is exactly what we want. Number 4 is like your quiz on Monday is going to be. So let's see how it goes. What is your thought? Change it into sines and cosines. I think that makes sense, especially since obviously junk's going to have to cancel because I'm only going to be left with that. So 1 over sine cosine times cosine over sine. Is that okay with everybody?
Yeah.
So I've got 1 over sine minus, what's this? You got to multiply this together. What does that become?
Cosine squared over sine.
Cosine squared over sine. Now normally at this point you'd need to get a common denominator, but you already have one.
So cosine squared over sine.
It should be sine squared over
1 minus cosine squared is sine squared. So you've got sine squared over sine, which is just going to cancel into sine. Anybody have a question about that? And then the bonus question is one like we just did, except, oh, how are we going to do that? I don't have a formula for the cosecant of x minus y. I don't have a formula for that.
When you find the sine, then just flip it over.
Oh, find the sine, pretend that it's a sine problem, and then when I get all done, flip it over. So if you remember, the other one we did, we got like 56 over 65. So then we would just flip it and say 65 over 56. Okay? All right. We're not going to do that because we don't have much time and I want to get to your homework questions. Does anybody have something from the homework that we need to look at? Anybody have a question about a homework problem? Yes, Alexis. 7 says the tangent of 5 pi over 12. Well, the first thing we're going to want to do, Alexis, is probably take care of that 5 pi over 12. Because I'm not too good in radians. So the tangent of 5 pi over 12. Okay, so I know pi is 180. Divided by 12 is 15. Times 5 is 75. So this is the tangent of 75. Now that's doable. Tangent 75, I'll break 75 into, that makes perfectly good sense to me, 45 and 30. And then I gotta do my formula. Remember, we don't just distribute, we got a big formula for this. So the tangent of 2 angles added together, that is the tangent formula.
Tan 45 plus tan 30.
Right. Okay, well then we'll work on this Monday. All right, remind me. Have a good weekend, people. No hugs, but I'm sending you a virtual one. I'll see you Monday. Quiz on Monday. Quiz on Monday. Excuse me. Bye. Have a good weekend.